Hey guys, Zong here, back in another math video. Next week is AMC 10 and 12. I wish you all good luck. And today we're going to be doing an AMC 12 problem. Take a look at the problem. Pause if you need to. And without further ado, I'm going to go on to the solution. So if I can get my pen working, which I can't. Oh, whoops. Okay, so this problem may seem intimidating at first, especially that word disjoint intervals. It's pretty intimidating. The disjoint interval is essentially like intervals that do not intersect each other, and that's not going to be a very big concern because in this question none of the intervals will intersect each other. So what this question is asking is essentially, given x, my pen pressure is not working, from 1 to 2014. X is in this. There are going to be some intervals, like let's say this interval, or this interval, or this interval, in which f of x will be less than or equal to 1. That's the condition. So in x is in these intervals between 1 and 2014, f of x will be less than or equal to 1, and we want to find the total length of these intervals. So that's what the question is asking. So, if we want to find that, intuitively we should just solve this for x. So we know f of x is this. That's less than or equal to 1. Well, let's solve for x. Let's solve for x. So 2014 1 over x. Because you divide both sides by the floor of x plus 1 as we move this over, which is actually also equal to, if you make this x, floor of x over floor of x. So we have that. So then we take the log of 2014 of both sides. So, and then we get x minus floor of x less than or equal to 14 plus 1 over this. So x is less than or equal to So we're left with this. So, given any x, x has to be less than the floor of x plus log 2014 floor of x plus 1 over floor of x. Well, keep in mind that x has to be greater than the floor of x, right? Considering the floor of x is the greatest integer less than x. So we also have this. So it's greater than or equal to the floor of x. And thus we have our interval. This is our interval. For any x, x must be greater than the floor of x, but less than the floor of x plus log 2014 floor of x plus 1 over floor of x. What's the length of this interval? Well, the length of this interval, if it goes from, say, if this is the line, it goes from this to this plus a log, then the length of this will just equal log 2014 floor of x plus 1 over x. That's the length of the interval, right? The length of this is just this, because it starts at floor of x. So the length of each interval is equal to log 2014 floor of x plus 1 over floor of x. And what can the floor of x be? Well, x is less than 2014, so the floor of x can be all integers from 1 to 2013. So essentially the question becomes 2013 okay, that seems still pretty hard, but at least we simplified it down. But you notice that here's a cool trick about logs, that if you have log base AB plus log base AC, and you add them together, you get log base A BC. So what happens is, this is equal to, if you add this together, so log 2014, let's start with 1 plus 1 over 1 plus log the 2 plus 1 over 2 plus log 3 plus 1 over 3. That's equal to log 2 over 1 times 3 over 2 times 4 over 3 dot 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 2014 over 2013, and these all cancel out. It's a telescoping thing, and we finally get log 2014 of 2014 over 1, and log 2014 of 2014 is just 1. That's the answer. The answer's A. Pretty cool, huh? I mean, if you look at the answers, actually, you see that some of them have logs in them. Sort of makes you know that you have to take the log of something at some point. So sometimes the answers can give you hints. I think it's a pretty fun problem. It looks intimidating, but if you really, I think a lot of questions at AMC12 look intimidating, but if you really just bash it out and really try, like without fear, I think you can get a lot of them. So, yeah. 2x plus -1. What has to happen in that case? Well, in that case, we want this to be odd, right? So we want this thing